All right, get ready for this. We're about to jump into a story that honestly sounds almost made up. It starts with something incredibly simple, a computer stuck in a wall, and it ends up at the absolute bleeding edge of artificial intelligence. It's this incredible story about how the human brain, and now, yeah, the silicon brain, might just learn best when there's no teacher around at all.
And it all starts with this one idea from a researcher named Sugata Mitra. This is the key to everything we're about to talk about. It sounds so simple, right? Children will learn to do what they want to learn to do. But that single sentence, man, it just turns decades of traditional education completely on its head. It basically says the real engine for learning isn't some fancy curriculum, it's just pure curiosity.
So, this was the question. This was the brilliantly simple, almost crazy question that kicked off a global phenomenon. Back in 1999, Mitra decided, okay, let's test this theory out. He literally took a computer, stuck it in a wall in a New Delhi slum where kids had never even seen one before, hooked it up to the internet, and then he just walked away. No instructions, no teacher, nothing. What do you think happened?
Well, the results were, they were just staggering. Within a few hours, you had an 8-year-old teaching a 6-year-old how to use the mouse and browse. A few days later, these kids were downloading games from Disney.com and recording their own music. And this wasn't some one-off fluke. Mitra did this experiment all over the world, and the result was always the same. When you leave groups of kids alone with the tools, they can teach themselves pretty much anything.
Okay, so browsing the internet is one thing, but Mitra wanted to know where's the limit. So he set this just impossible goal. He said, okay, can a group of Tamil-speaking 12-year-olds in a village teach themselves graduate-level biotechnology from a computer that's entirely in English? A language they didn't speak. He honestly expected them to get a 0 on the test. He was very wrong. So after 2 months, he went back to check on them, and a 12-year-old girl actually said this to him. Just let that sink in for a second. It's so funny and at the same time so profoundly shocking. They didn't just pick up the language. They figured out the core concepts of molecular biology just by working together. It's incredible. And this is where the data just gets really, really interesting. On their own, with no help, the kids' test scores jump from that expected 0 all the way to 30%. That's basically an educational impossibility. But then, Mitra added one more little thing to the experiment. He found a local woman who knew nothing about the subject and just asked her to encourage them.
He called it the method of the grandmother. Her only job was to stand behind the kids and just admire what they were doing. To just ask questions like, wow, that's amazing. How did you figure that out? Can you show me? And with just that one layer of encouragement and admiration, their scores jumped again, up to 50%. That's the same score as kids in elite private schools with specially trained teachers. Just incredible.
And this is where our story takes a hard right turn into the future. Because this principle, this idea that you can learn through self-discovery, through collaboration, and just a little bit of encouragement, well, it's not just a cool theory about education anymore. It is the very model that AI researchers are now using to build the most powerful learning machines on the planet.
Now, to really get this, you have to understand that there are basically 2 ways to learn. There's what we call off-policy learning. Think of that like reading a textbook. You're just passively soaking up facts someone else organized for you. But then there's on-policy learning. That's learning by doing. It's messy. It's active. You make mistakes, you try things, and you get real feedback from the world. Those kids at the hole in the wall, they were the ultimate on-policy learners.
So for a long time, a lot of AI was trained off-policy. We basically just fed it the entire internet, like a giant textbook, and told it to memorize everything. But to get to that next level, to build an AI that can actually reason and solve new problems, well, researchers realized it needs to learn like those kids did. It needs to learn on policy, from the consequences of its own actions.
And this whole process has a really cool name, self-distillation. And it's exactly what it sounds like. The AI model is both the teacher and the student. It tries to solve a problem, it probably gets it wrong, and then it analyzes why it got it wrong. And it uses that valuable feedback to update its own brain for the next try. It's literally teaching itself how to be smarter, over and over again.
The way this often works is with a teacher-student model. And this is where it all comes full circle, right back to that granny cloud. The teacher AI doesn't get a reward when the student AI gets the perfect answer. No, it gets rewarded when the student shows improvement. The entire system is built to encourage the process of learning, not just hitting the final target. Sound familiar?
Okay, so this isn't just a fascinating story about slums and supercomputers. The big takeaway here is that this core idea, that real deep learning is active, it's self-directed, and it's powered by curiosity and encouragement. That has huge implications for how we can help our own kids learn, right in our own homes.
So let's make this super real. We're going to turn all this high-level theory into a practical little experiment you can try at home. I want you to start thinking of yourself not as a teacher who's supposed to have all the answers, but as a facilitator of curiosity. Your new job description is simply this: be the Granny Cloud.
Here's how you do it. Step 1. Pose a big, juicy question, something you might not even know the answer to yourself. Don't ask, what's the capital of Spain? Ask something huge, like, how do airplanes actually stay in the sky? Or, why do we dream? Step 2. Give them a device, a tablet, a laptop, whatever. Step 3, and listen, this is the hardest part for most of us, step back. Your only, and I mean only, job is to be that encouraging presence. No giving hints, no giving answers, just admiration. Wow, that's so cool. How did you find that? Or tell me more about what that means. And that kind of leaves us with this one final really big thought. We spend so much time and energy trying to give our kids the right answers. But maybe what Sugata Mitra and the AI labs are both showing us is something totally different. Maybe our most important job isn't to provide any answers at all, but to get really, really good at asking that one big question, the one that's so compelling, so fascinating that learning just becomes absolutely, totally unstoppable.